Good morning, dear students and fellow colleagues. I am Mr. Lucky Klaba. Today we are doing mathematics, the topic known as differential calculus, and I'd like to welcome you to National Tutoring Campaign. Under differential calculus, we have first principle, where would be requested to solve the equation using first principle or by definition. There is a formula which would be given to us to use for first principle. So first principle amount to about 6 to 7 marks, okay? So do know that would be asked to use first principle to solve different questions. So make sure that you are able to use first principle. And we have rules of differentiation. You'd also be asked to use the rules of differentiation in solving the question. You would also be asked to use the average gradient. You would have to also use the average gradient for you to solve the equation of a tangent. So make sure you know how to solve first principle for different questions, okay? And how to use the rules of differentiation, how to get the average gradient, and also how to get the equation of a tangent. I'm gonna be showing you as to how you are able to move from getting first principle, use rules of differentiation, getting average gradient, and equation of a tangent. Okay, so first principle, I think you know it by now. Okay, it would be f prime of x. Okay, this is what they would want you to do, which is equals to a limit. It's gonna be a limit when h tends to 0, okay, of f at x plus h, okay, when it's subtracted from f at x. When it's subtracted from f at x, all this should be over h. So that is the first principle. It's gonna be given to you in the formula sheet, okay? So rules of differentiation, I think you guys know. Under the rules of differentiation, we have a generalized rule that if maybe y is equals to a into x to the exponent of n, all right? So the derivative of this, which is dy, if we derive it with respect to x, so dy dx, okay? Your dy dx is going to be your a, okay? It's gonna be your a. Let's erase this. It's gonna be your a, okay? So it's gonna be your a, which will be multiplied by your n. The exponent comes down, it becomes a multiplied by n, then a multiplied by n, all right? Then from there, the x is going to be x n minus 1, okay? So it's gonna be now a multiplied by n, then x into n minus 1, okay? Please do note that this is multiplication, so as it cannot confuse you. So I can even put a dot to show you that it's multiplication, okay? So That would be how it would look like. A multiplied by n, x n minus 1. So that is your derivative, the rule for differentiation. Then we know that when we differentiate a constant, the derivative of a constant is 0. Now we have an average gradient, okay? So you guys know that we can get an average gradient, okay? So you can have an average gradient. So average gradient, it would be your change in y over the change in x, okay? Between whatever point which would be given to you, okay? If you like, we can say it would be f at point B minus by f at point A, close bracket, then over B minus A. So the average gradient is between the 2 points, which is the value of y at B and the value of y at A, then subtract by those values, okay? Then we have an equation of a tangent. Remember, a tangent, it's a straight line that touches a curve at one point. So because a tangent is a straight line, so the equation of a straight line, it will then be y is equal to mx, okay, plus c, all right? So that is your equation of a tangent, okay? So make sure that you know how to get the equation of a tangent. Of course, the m in this regard, it's your gradient, and your c is your y-intercept. So this is what we'll be looking at today, the first part of differential calculus. Now, the important thing under differential calculus, which are examined and non-examinable, is that the f at x, okay, the f at x can be denoted differently. The f at x can be denoted differently, okay? So the f at x can be noted differently. So it's f prime of x, which is the derivative with respect to x, okay? And also the dx, we can use the x, which is derivative with respect to x, or we can use the y dx, which is derivative of y with respect to x, okay? Or it can just be the y prime. So please make sure you are familiar with all different notations. They mean exactly the same thing, all right? And do remember that when we find a derivative, what we basically trying to find, we are finding a gradient at the point. A derivative is actually a gradient at the point. So now let's see what would be given to us. I've already mentioned to you, there would be this formula, okay? First principle. So you're gonna have this, that's your formula. It's your first principle, okay? Please make sure that you remember this. This is your first principle, okay? So it's your first principle and it reads f prime, okay? F prime of x, f prime of x is equals to a limit, okay? Where h tend to 0 of f at x plus h minus f at x all over h, okay? So that is our first principle. Please remember, even in your formula sheet, go and write the following at the top, that this would be used for first principle, okay? So that is our first principle. Now, from first principle, if they're gonna give us f at x, this one would be given to us. The f at x would be given to us. The only thing that we have to get for ourselves, it will be f at x plus h. So everywhere where we see x, we're gonna substitute x plus h, okay? So that is what we're gonna be substituting, all right? Then make sure that you have the limit which tends to 0, okay? And please remember this prime, f prime of x. So because if it does not have that, it loses its meaning. It does not become the derivative anymore, okay? So make sure that you remember that. That is then to say, write the equation as it is given to you in the formula sheet, all right? Then from there, below we have another set of equations. So this would be the equations that we're gonna use for a tangent. This will be our gradient. And we know that the C, it would be the y-intercept, okay? So remember that your C would be your y-intercept, okay? And your M is gonna be your gradient, all right? So your M is going to be your gradient. So that is the equation of a tangent. And a tangent, like any other straight line, it conforms to this equation. Other students, I know they prefer to use this equation. It's exactly the same as the previous one. The only difference is when you use this equation on y1 and x1 is your point that you would be substituting, okay? So this would be the point that you'd be substituting, okay? So remember, after you get a gradient, you'll have to take 1 point and substitute. So this y1 and x1, it's actually the point that we will be substituting. All right, so you have your gradient, then this is your gradient. Remember, I told you it's your change in y over the change in x. The important part here is make sure that your point that you have chose is x1, y1. Another point would be x2, y2. This is your formula sheet, okay? So in this formula sheet, make sure that everything you write, for instance, this we're gonna use them every time we have a what? A straight line, okay? I'll just shorten it and say just a straight, okay? So this is a straight line. So make sure that you use this every time when you have a straight line. And in this regard, a tangent is a straight line. Okay, so let's see some of the important information about this topic. So I would continuously reminding you about the format of the question paper. So as you are well familiar with what you have to expect. For your information, this topic, differential calculus, there it is. This topic, differential calculus, is part of paper 1. So please make sure you know exactly where does it belong. It's part of paper 1, which would be examined over 3 hours. Please remember paper 1, 3 hours, and the total marks possible, it's 150. Okay, in our final paper, even now during the trial examination. And let's see how much now this topic can give us. Under the weightings of the paper, we can look at differential calculus, okay? We can look at differential calculus. When you look at differential calculus, you can tell that in this differential calculus, you can be given about 35 marks. So differential calculus is about 35 marks, okay? But today we are not going to do the whole of 35 marks. We are going to look at the first 15 marks, which is the easiest mark that one can possibly get. So the first part of 15 marks is gonna be the focus point for today. And of course, for next week, then would then look at the remainder where we look at the cubic graph. Okay, so let's see how then we go about getting our 15 marks. But before we do that, it's important that we follow the instructions and information which will be given to us. Okay, so we need to check that how many questions the question paper consists of. because if we know how many questions the question paper consists of, it makes it easy for us to then plan accordingly and check as to how are we going to tackle the paper. This is to say, which questions are we going to start off with and which questions are we going to end with. So that part is very important for us, okay? So as to pace ourselves correctly, that we use that whole 3 hours accordingly, okay? And starting with the questions that we are mostly comfortable with. Okay, so that is instruction 1. This question paper consists of, so a certain day they will tell you how many the question paper consists of. Then please pace yourself accordingly. Answer all questions. Learners, I know in different subjects, particularly in languages, you are given a liberty to choose which questions to answer and which not to. But in mathematics, let me reiterate this. We answer all the questions. There is no optional questions. So we answer all questions. Make sure that there's no question that you are going to skip. We answer all questions, okay? Even those that we are not most comfortable with, we still answer and make an attempt. Possibly our attempts would be awarded marks. So please make sure that you answer all questions. The second part, number the questions correctly according to the numbering system used in this question paper. You're gonna number the questions correctly according to the numbering system used in this question paper. Okay, so the numbering system used in this question paper, it's very important. Okay, so we are going to be answering all the questions and number as it's numbered in the question paper. We have to clearly show all calculations. So please do not make calculations only in a calculator, then you write the final answer on your answer script. Show all your workings, show all your calculations, even the diagrams or graphs that you have used in determining your answer. They should be visible so as you can be awarded the full marks. The good part here is answers only will not necessarily be awarded full marks. If you're just going to do the answer in a calculator, students, then you write for us a final answer. Do take note, you are not going to be given the full marks, okay? You may use, of course, approved scientific calculator, which is the one non-programmable and non-graphical, unless it would be stated otherwise. If necessary, please, we round off our answers to 2 decimal places and we do the rounding off in our final answer, okay? So we round off our final answer to 2 decimal places. If there are any diagrams given to us, let's remember that the diagrams are not necessarily drawn to scale, okay? So do not just look at the diagram and try to think that maybe a certain point would be how much. It's not correct. Use information sheet, okay? So use information sheet like the one I've shown you. Use information sheet, okay, with a formula that is included. It's always included at the end of the question paper. Make sure you make use of it. And of course, write neatly and legibly, okay? So these are not necessarily drawn to scale. Remember the 2 decimal places. Please bring with your scientific calculator, the approved one, and answers only will not necessarily be given the marks. We have to show all calculations, okay? And we number correctly. We number correctly and we answer all the questions, okay? So those instructions are important and I'll make sure that I continually read them for you and explain what is expected of you. So now I think we are in a position whereby we can look at a typical question. So there is our typical exam question. A typical exam question on this particular section would start with us answering the first principle questions. Okay, so it says determine, okay, it says determine f prime of x. So we are needed f prime of x if we are told that f at x is equal to 2x squared. Okay, f at x is equal to 2x squared minus 1. So we are asked to determine from first principle. So it's important that you understand that in this question, the examiner explicitly want us to get the answer using first principle. If you can choose to do it differently, you are going to lose the marks because you will have not followed the examiner's instruction. And as I've said, the first principle, it's about 5 to 7 marks. Okay, so first principle is about 5 to 7 marks. All right, so now let's see how we go about first principle. Okay, let's see how we go about first principle. So let's go to the next slide where we now have to work out the first principle. Okay, let's go to the next slide whereby we would be working out first principle. Okay. So it's 7.1. You see, I'm also using the numbering system that it's given here to me. Okay. So now let's look at the possible solution to this. Okay. So we are given the following. Okay. We were given that f at x. We were given that f at x. Okay. We were given that f at x. There is our f at x. It was given that is equal to 2. Okay, we are told that is equal to 2x squared minus 1. Okay, so this is what we are given for first principle. Let's have a nice 2 here. Okay, let's have a nice 2 here. So this is what it was given to us. Okay. I want to make it big. Aha, Darse. So now this is what it was given to us. F at x is equals to 2x squared minus 1. Okay. So now the first thing that we need to do, I told you, we have to get f at x plus h. Okay. We get f at x plus h. Okay. We get f at x plus h. What is this f at x plus h? Is to say everywhere where we see x, now we don't put x, we're gonna put x plus h. So it means I'm going to write 2 as it is. Where I see x, I now write x, okay, there is our x plus h, okay. But this was squared, so I have to also square. Then this is minus 1, okay. Then this is my f at x plus h, but I can choose to simplify it further, okay. I can choose to simplify it further. I can write 2 as is. According to BODMAS, I have to work out whatever is in bracket first. So what is in bracket, it will give me x squared, okay. We can use FOIL, or if you don't want, you can use by inspection. This one I know you master. So which is 2 xh, okay, plus h squared, plus h squared, okay. And of course, this is still minus 1. So now you can choose to multiply everything by 2. If you do that, now we're going to have 2x squared, okay, plus 2 multiplied by 2 is going to now give us 4, okay, xh, okay, plus 2h squared, okay, minus 1. So now that would be our f at x plus h, okay. Now, to make sure that we do not have our things messy, now what we can do in our formula, remember, it has what? It has f at x plus h, okay. It has x plus h minus, remember, you don't have to remember it by heart. It is given to us in the formula sheet, minus f at x, remember. So we can subtract this 2. So we can subtract this 2x squared, okay. It means we are subtracting this bottom one with this one. So it will be 2x squared plus 4xh, okay, plus 2h squared, okay, when it's subtracted from 1, but we need to also subtract, okay. You subtract your 2x squared, which is your f at x, okay, minus 1. So please remember, when we subtract, we always open the bracket. So now we can remove those brackets. It would be 2x squared, okay. It would be 2x squared, okay. So we'll have our 2x squared. So our 2x squared, there it is. Then this 2x squared, okay, there is our 2x squared plus 4xh, all right, plus 4xh. Remember, we want to remove the bracket, plus 2h squared. This we write it as is, by the way, minus 1 minus 2x squared. And remember, a negative and a negative now. What is it going to give us? A positive. It's going to give us positive 1. Okay. So this is what we are going to have. Thereafter, you can collect the like terms. Okay. You can collect the like terms. You can collect the like terms. As you collect the like terms, you get 4xh, because 2x squared minus 2x squared is going to cancel out, and minus 1 plus 1 will also cancel out. So we are left with only this, 2xh plus 2h squared. Okay, so that is the only thing that you're going to be left with. Are we together? So that would be the thing that we are left with. All right. So afterwards, now you can substitute everything in our equation. Okay. You can substitute everything in our equation. Okay. So remember, equation of first principle, say f at x, okay, is equal to a limit, okay, is equals to a limit when h tends to 0. When h tends to 0 of f at x, I wrote it for you before, so please do write it again. F at x plus h minus f at x. Everything should be divided by h. Good, so this is our equation. So you can substitute everything here in this equation, okay? Already we have f at x, so it means we are going to keep a limit as is, okay? So you're gonna keep a limit as is, and you say h approaches 0 or tends to 0. Then where you see f at x plus h, you write this because we already determined. So we determined it to be 4 xh minus 2 h squared. Okay, it's plus rather. Then this one we have. After we have this one, now we have to divide everything by h. Okay, it said everything should be divided by h. So you divide everything by h. Then you take out h as a common factor. Okay, you take out h as a common factor. So you have a limit. Okay, where h tends to 0. Okay, then you take out h as a common factor. When you take out h as a common factor, there is h. Then of course here you're gonna left with 4x. Okay, you're gonna left with 4x plus 2h. Okay, or we can even write it below. We can create a nice space for us, and we can write it below. So let's put it right here. So when we remove h as a common factor from above equation, it becomes a limit is still there. Remember, we have a limit. So please never forget to put in the limit, because now it's going to make you lose marks as it lose the meaning. Okay, so it's gonna be a limit. Okay, then where h, I think you understand now as to why they give you 5 marks. It's quite long. Okay, so we want to make sure that we get it right because it's very easy. So it's h, then you've got your 4x. When you take out h out, you've got the 4x plus here, when 1h is out, we are left with 2h. Okay, very good. Then everything is subtracted by h. I think you'd see that the h and the h are going to cancel each other. As a result, okay, after they cancel each other, we can now allow our question to take h of 0. Okay, then it will be 2 multiplied by 0, it will be 0. So it means the only thing left now, it will be our 4x. That would be the answer. It's 4x. And you guys now know some rules, so we can even confirm if this is correct. We say from here, the 2 comes down, is 2 times 2, which is 4. Then it's x2 minus 1. So yeah, it's gonna be the correct thing. So that's how we work this one out. Okay, so you'll get your 5 marks rather. All right, other questions they give you, and I know some of you would say, how are you going to get the marks? Let me show you. You'll get this mark. Okay, and also get the mark for substitution, okay, a mark for simplification, okay, then also a mark for working this one out, and of course a mark for working this one out. That's how you're going to get your good 5 marks, okay? So make sure you know how to work this one out. All right, so now 7.2.1. So let me just remind you, what did they ask of us? There it is. They say find a derivative of this with respect to dx. Okay, so we want the derivative with respect to dx. All right, so the first thing that we are going to do when we find this derivative, we are going to start by removing the set. Okay, so we don't want this set. Okay, so as we can use the rules of differentiation, we don't want this set. So now let's see how we are going to work it out, because now we don't want the set. Okay, so now this is how we're gonna be solving this one. So they say they want the derivative with respect to x. Okay, they want the derivative with respect to x of which function? It's a fifth. Okay, it's a fifth root of x squared. Okay, it's a fifth root of x squared plus x cubed. Okay, plus x cubed. So it's a fifth root of x squared plus x cubed. All right, so the first thing for us to do now, before we can even find the derivative, we have to write this in a fashion that we know how to differentiate. Okay, so guys, I think you remember this. When it comes out, is going to be 2, okay, x into 2 divide by 5. Okay, remember this fifth root, it becomes a denominator and this remains your numerator. Okay, it's gonna be added. Okay, it's gonna be added. Okay, then it's gonna be added to x cubed. So the x cubed, we are not going to do anything to it because it's exactly as how we want it. Okay, so now we differentiate. So when we differentiate this, now what would be our answer? Okay, so our answer now is going to be 2. Okay, it's going to be 2 all over 5. Then the exponent jump down, it becomes 2 over 5. Okay, then it's gonna be your x. Then this 2 over 5, we are going to subtract 1. So if you subtract 1 from 2 over 5, it's now become -3 all over 5. Okay, so this is when you subtract 1 from your exponent according to the rule. Plus, now is the 3 which jumped down, is the 3. Then we've got your x, you remain with it. Then your exponent, you subtract 1. So it's left as 2. So that is the rule. Please remember, the rules say you take the exponent, we multiply it by the coefficient, you remain with your variable, then the exponent of the variable, you have to subtract 1 from that exponent. If you subtract 1 from that exponent, then it becomes your answer. And lest you forget that a derivative of a constant is 0. Okay, so do not forget that the derivative of a constant is 0. All right, so let's go and look at our last question. Okay, so we're gonna look at our last question. There is our last question. Okay, so there is a last question. So they want a derivative of f of x. Okay, so where x cannot be equal to -3/2, because if it becomes that, it becomes mathematically undefined. Okay, so now let's go and look at the question. Okay, there is the question. Let's now get the solution. Okay, so the question, they want derivative of f at x. But what is their f at x? F at x is equal to 4x squared minus 9. Okay, minus 9 minus 4x plus 9. Okay, or rather 6. Okay, so this is the first thing that we have. So if we are given something like this, before we can get f at x, we have to factorize. So this is a difference of 2 squares. So it's gonna be 2x minus 3 close bracket into 2x plus 3. Okay, then everything is all over. We also factor out 2 here. Okay, common factor is 2, then we are left with 2x plus 3. So this is what we do. We factorize, because we cannot get the derivative if our function is given as follows. So we factorize, so as whatever cancel out, cancel out. I see 2x as numerator, 2x plus 3 and 2x plus 3 as denominator. So the 2 are going to cancel out. If they cancel out, now you are left with 2x, okay, minus 3, because the 2x plus 3 has canceled out, and it will be divided by 2. Okay, so it will be divided by 2. So this is now how our function is going to look like. After you have got this function as follows, now we can do what? We can divide. Okay, we can divide 2x and 2. It will give us x. Okay, then you can divide this one, which is minus 3 divided by 2. You see, I've not wrote f at x prime as yet, because I have not arrived where I'm differentiating. Only now I can come and say f prime of x, which is a derivative with respect to x. It's a derivative of x, okay? And derivative of x, it's, as we know it all, is equal to 1, okay? Then it's equal to 1, because the derivative of a constant is going to give us 0. So the final answer then, f prime of x, would be equal to 1. Then we'll get our good 4 marks, okay? Where the mark would be given for an answer for simplification, okay? We're gonna get the answer for simplification, and we're gonna get answer for factorizing the numerator, as well as the answer for factorizing denominator. And yes, yeah, that's it. Now we are able to get our final answer, right? So we were able to answer all the questions, okay? From first principle all the way to the last question, okay? And of course, I cannot just leave you without having you to have an activity that you can do while you are still at home trying to practice. Remember, with maths, practice is the only remedy to make us perfect in mathematics. Yes, that's your home activity. So it says you need to get the derivative from first principle. That one you know. You also have to get the derivative, dy dx. You also have to get dy dx and dy dA. And the last one, of course, it's when now you have to get the equations, maybe of a tangent, okay? So yeah, a line perpendicular to a tangent. So that would be the equation that you get. So this is everything that we spoke about regarding the differential calculus. And that's it from me. And I thank you. If there would be no question, we have arrived at the end of our lesson today. And thank you very much for your time. And I thank you. Till we meet each other again next week. Next week, do remember we're gonna be looking at cubic functions. Thank you very much.